Alright, so the next thing we need to do is we want to, thinking of the 3 steps that this circuit's going to do, we got it to fire the solenoid. Now we need to make it to change the flux. And we'll do that using a potentiometer. And we'll go ahead and wire that in to the breadboard here. Now the outside legs of the potentiometer are the positive and negative. So we'll just wire those in. And you can put those directly into the ground of the Arduino and the 5-volt output of the Arduino. And in the center is the wiper of the potentiometer. And that one needs to go to an analog input on the Arduino, which these 6 pins here, these are all the analog inputs that the Arduino has. And we'll, and again, it doesn't really matter which one you put it in, but we're going to put it into A0. And now we come back over to the computer and we need to tell it what to do with this potentiometer. So right at the top of the class, we need to set another characteristic. We need to do the sensor pin, I guess we'll call it. And then again, inside the solenoid drive with this integer here, we need to do actually no, we don't need to use that right now. We just need to use we just need to make it work with the potentiometer, and that pin, the way we're going to do it, we don't need to set that there. So into the function, we need to map the potentiometer. Now the potentiometer has values from that's read by the Arduino, that's 0 to 1023. Now we don't want to use those values, because if we set it all the way to 0, that's going to stop the motor completely. And then to get it going again, we'll have to, flick it with our finger to get it moving, which isn't a huge deal, but it would be better if you can turn it down to a real slow speed and it not turn off. And we don't want to use the full 1023, because that will make the motor run away and it's likely to fly apart. So we need to map the potentiometer to lower values, or slightly higher than 0 and quite a bit lower than 1023. And the way that we do that here is we're going to set another integer and we'll call it value. And we need to map the potentiometer, and it's an analog read because we're reading from the analog input. And we'll do sensor pin, and we need to map it from 0 to 1023, and we want to map it to, well, we'll say from 0 to 10, and then 1023 to say 250. Those sound like good numbers. I'm not going to know exactly what numbers to use until I get the solenoid connected to the circuit, and then I can adjust those values from there. And now we need to change these here. Because we're using it to feed the LED, this is no longer going to be a digital input, or an output rather. It's going to be an analog output. And we need to use analog output so we can take advantage of the PWM function of that pin. So we'll leave the delay, but we're going to change this. So we'll do an analog write solenoid pin, and we want it to be the value that is set by the potentiometer. Then again, we'll do a delay of 1 second, and we need to change this to analog write, and we need to change low to 0, because the analog outputs do not read the highs and lows. Those are only for digital. Now that we got that set, we can upload it to the, and again I got another, I think I just misspelled sensor pin. We'll just copy and paste it here. Yep. Now we can upload it to the Arduino and it's done. Now you can see that it's blinking and we've got the potentiometer turned down as low as it'll go. And if we turn the potentiometer up, you can see that the LED is getting brighter and brighter. Therefore, we're changing the flux of the solenoid, causing it to go faster and slower. Okay, we got the first two operations of the circuit completed. We got the Arduino to fire the solenoid, and we got the potentiometer wired in so that it changes the magnetic flux of the solenoid. The next thing we need to do is to create the switch that will tell the Arduino what position the solenoid or the solenoid motor is in. And the way that I'm going to do that is I'm going to use this little guy, which is a latching Hall effect sensor. Now the way that this works is you have the leg on, if you look at it from the top here, you can see that one side is flat and one side is curved. The curved side is the face. If you're looking at the face, the pin on the left is the positive, the middle pin is the negative, and the pin on the right is the signal. Now another thing we need to do to wire this in is we need to use a resistor to connect the two outside pins. I'm not sure why we need to do this. This is what's called for in the spec sheet for this Hall effect sensor, so that's what we're going to do. And the way that this Hall effect sensor works, of course, as all Hall effect sensors work, is a magnet actuates it. But what's cool about this one, it being latching, is the north pole of a magnet will turn it on and the south pole will turn it off. That's how we're going to get the switching effect. On the motor that I build, I will have an eccentric that will have the magnets mounted on it, and as the magnets pass the switch, that's what will actuate the, or that's what will tell the Arduino to fire and turn off the solenoid. Then we won't have to have the delay like we have right now. So to wire this in, we'll stick these into the pins into the breadboard here. And then we'll use our resistor to connect the two outside pins. Now, like I said earlier, the outside pin, the left side pin, that is positive. So we'll connect that to the 5 volts of our Arduino. The middle pin is our ground. And then the middle, or the left side pin, is our signal. And we'll stick that into a non-PWM input. I'm just going to use pin number 4 because it's convenient and it's right next to the PWM signal we're using for the solenoid. Alright, so now we got that wired in. What we need to do now is tell the Arduino what to do with it. So we'll come back over here to our IDE, and again we need, since we're using a new pin, we need to set that pin. So we'll do an integer switch pin, and then we need to tell it what type of pin it is. So it's a switch pin is equal to trig pin. And then we need to set our new variable in the function, so integer trig pin. And then just like before, we need to tell the Arduino what type of pin it is. So it's pin mode, switch pin, and this one is going to be an input. And then down here where we create our instance of the solenoid, we need to add the pin for the switch. Now inside the function we need to change it up a little bit. Now we want to fire the solenoid while the switch is on, and we need it to turn it off when the switch is off. And the way that we're going to do that is to use a while loop. So while the switch pin is equal to low, or sorry, to high, we want to map our potentiometer. We want to update our solenoid, and that's it for the function. And then outside the function, and it'll do this over and over again until the switch is turned off. So after that we'll go to outside the while loop. Once the while loop is completed, it'll come back out here and we'll want to turn the solenoid off. We'll remove the delays. So it'll come into the while when the switch is on. It will map the potentiometer and write that value to the solenoid. And then once the switch turns off, it'll jump outside the while loop and it'll turn the solenoid off. And it'll come back down to the void loop here and it'll start the process all over again. So now that we got that written, we can upload that to our Arduino. Uploading is done. Now I've got a neodymium magnet stuck to my machinist rule here, and we'll just wave that in front of the switch. Huh. Interesting. Why you no worky? Now we're going to pin 4. We got our positive and our negative. We got our resistor. Let's see. Let's go through it again. So we've got our switch pin. It's set to trig pin. Switch pin is an input, while the switch pin, I see. So we need to do this. See, I make mistakes. Let's see, while digital read switch pin is equal to high, then we'll turn the LED on. Alright. Updating. Upload complete. Now it should work. Switch is on. Switch is off. Now, like I said before, I'm not going to be using this big of a magnet, but I'll be using smaller neodymium magnets that will be attached to an eccentric, and the eccentric will pass by the switch and turn it on and off, similar to what you're seeing here. And because the flux is going to be changing, that's going to change the speed of the motor and the speed at which these magnets pass the switch to turn them on and off. And of course, again, we can still change the flux, and then we can switch it off. As I said earlier in the video, I plan on making this a dual solenoid motor. So we need to add the second solenoid function. So I've got, and this is extremely easy. So we'll take another LED and we'll put it on this side. We'll need our resistor, connecting it to ground. And then we need to connect it to the other pin to a second PWM signal from the Arduino using pin number 6. And then we'll use another one of our switches. We'll add this to the circuit. With our resistor connecting the 2 outside pins. Then we have the left side pin connected to positive. There goes my LED. Left side pin connected to positive. The positive 5 volts. The middle pin connected to ground. And then our signal pin connected to another input of the Arduino, which we'll use 7 because it's right next to 6. And we'll put our LED back in here. Alright, now for the cool part. Back over here on the IDE, we can change this up ever so slightly. Actually, very, very slightly. The only thing we need to do is we need to change this and change this. Everything else will stay the same. So all we need to do is to create another instance of Solenoid. And we'll call it Solenoid 2. We'll call this Solenoid 1. And then this one will be pin 6 for the output and pin 7 for the switch. Now down here in the loop, we need to change this to 1. Then we'll do Solenoid 2 update. And that is it. We upload that to the Arduino. Now we have dual piston or dual solenoid motor. And again, we can change the flux. I'll turn it all the way down so you can see that it lights up very dim. And we'll turn the potentiometer back up. Alright, just to recap our thought process here. Remember that we thought about what our entire circuit was going to entail, what we wanted it to do. We broke it down into 3 separate sections. Firing the LED, or the solenoid, adjusting the magnetic flux in the solenoid with the potentiometer, and then switching to allow the Arduino to know what position the motor's in. And we did it step by step. And as you can see, when you go through step by step, you can be quite successful with it. Now, I did have a few mistakes, all of it being in the code writing I was doing. I had a couple coding errors and a couple misspellings. It happens, especially when you're trying to type and talk at the same time. But I do believe that this will work. I won't know for sure until I get the motor built, which will be coming up in an upcoming video. I'm not quite sure when I'll actually get to it. I do have some other projects lined up before I get to this one. One of them being this little motor. So stay tuned for that. And I also want to create a drawing for you guys so that anybody who wants to build this can build it. I want to have a drawing for the circuit so you know how to wire it up. I'm also going to provide the code that I wrote for the Arduino, and then I also am going to model the engine itself in Fusion 360 so that I can provide a drawing for you guys. And then anybody who wants to build one, using my plans, or if they want to modify the plans and whatever, you're more than welcome to do so. Anyway, I believe that'll do it for this video. I thank you for watching Basement Machinist, and I'll see you next time.